Hello and welcome to our second category of ionic compounds, looking at ternary ionic compounds. Remember within our flow chart, there was an option other than having just two elements within the substance. If my ionic compound that has a metal has three or more elements, it's going to have a different type of particle. Now, there's one exception to this where it may not have a metal, but it might have an ion called NH4 plus in the beginning. So if you say no, there's no metal, and you come over here and the first element isn't hydrogen, but you see nitrogen in the first position, you probably have ammonium. And we'll be talking about this category of rules. We still need to pay attention to whether the metal has multiple ions or not, and we're going to see the same adjustment in there. Excuse me, I sneeze. But we have a different set of criteria we need to deal with this different type of particle. So we're still going to write the name of the cation first, and like 90% of the time, that's going to be a metal. So remember, cations are the positive ions. 90% of the time, it's going to be a metal. The only time it's not is if you're going to have this molecule particle called NH4, which is ammonium. Then we would just write ammonium first. If the metal has multiple ions, remember that we need to put the charge as a Roman numeral. That will require you to determine the charge as we've done before. Lastly, we're going to write the name of the polyatomic ion, which is an anion, second. So these types of ions, these poly, meaning many, atomic, meaning atoms, it's an ion that exists as a group of atoms, so it carries a charge altogether. They have special names based on their formulas. So we can't change the ending, or that would change what it means, what it is. Now you might recall that when I handed out periodic tables, that I mentioned there was something on the back. So on the front, you got your nice periodic table with all your charges of these metals. On the back, you have this handy dandy reference list. This is a list of many of those common polyatomic ions. You'll notice for all the cations, the only one listed that has more than one element in it is ammonium. That's your only polyatomic ion that we're going to have to worry about. The rest of the polyatomic ions are negative. So you will get to use this with the exception of the 6 that are listed in your note sheet. Regular students, you will be provided all. Honor students, you have to memorize those 6. You will get to use this on tests and quizzes. So we just need to know how to look them up and find them on the list. So let's take a look at a few examples. Our first substance is Mg, and then it has this polyatomic, see 2 elements in it, ion in the negative position. Well, Mg on my periodic table is in column 2, which is the +2 column. So I know it has a +2 and only +2, so no Roman numeral needed. BrO4 on my list, as I look down here, I kind of know where to look, is called perbromate. So I'm simply going to write magnesium perbromate. All I had to do was look up the name of that polyatomic ion on the chart. One hint, it's a -1, and we might have known that because I needed 2 of them to cancel out this +2. That would help you know which column to look at in your chart. My second example is Cr3PO42. So I'm going to go look up Cr. And I notice that Cr has multiple charges. So I'm going to have to take a look and see which one I'm dealing with. To do that, I have to look at my PO4. If I look over here, you'll notice that PO4 is a -3 ion. And I don't know why my screen is flashing. I wonder if it did for you guys. So I have a -3 ion, and I have 2 of them. That gives me a total negative charge of 6. That means I need to have a +6 here. And since I have 3 CRs, 6 divided by 3 means they each are a +2. So that means I can write chromium. My Roman numerals are my charge, which is a 2. And the name of my ion is phosphate. Lastly, I don't have a metal in the first position, but I have that NH4 we talked about, which our rules say up at the top is ammonium. So I just write ammonium. My second one is a simple non-metal, so I check my periodic table, and I see over here it's fluorine. I need to follow my regular rules. So this would be fluoride. Since it's not a polyatomic, I do change the ending for this one. So still using our Roman numerals as we did before, but when I have a polyatomic, no changing the names. Leave the name whatever it is. And I just need to know to look it up on the chart. Now, how might this look in the formulas? You might have noticed that these formulas look a little bit more complex. The general, here's your list that you can check later for your answer key. For formulas, you'll notice the process is exactly the same as before. There's just going to be one adjustment that we have to use for our polyatomics. I still determine the charges, and I still determine that ratio that gets me to 0 charge. But now, when I have polyatomics where there's more than one, I need to use parentheses. What that does is it helps us see what you want multiples of, because a polyatomic ion is a particle that exists as a group. I can't split it up. If you do that and you don't write parentheses, you would end up kind of implying you need to split up the substance. So let's say that I was dealing with calcium nitrate. So calcium, based on our periodic table, is again in the +2. So +2, and my symbol is Ca. I check my chart and I find nitrate. It's right here. Its formula is NO3, and it has a charge of -1. So it's a -1 ion, and it's NO3. Now it's really important. This NO3 is a chunk that you can't break up. I got to keep that together. So if I have a +2 ion combining with a -1 ion to form a neutral compound, I have to get the ratio that gets it to 0. I would need 2 of the nitrates to cancel out the +2 over here. Notice that kind of follows our crisscross rule. So I'm going to need 2 of the nitrates and 1 of the calcium. If I wrote this, it kind of wouldn't make sense, right? It looks like NO32. So we use the parentheses to show what we have 2 of. I have 2 of the NO3s. Now, one more example. Let's say I had ammonium phosphate. In this case, ammonium, that's that one that's that different polyatomic in the front. If I look at my chart, my formula is NH4 plus. Phosphate on my chart we worked with in the last one. Phosphate is PO4 3 negative. Now you'll notice I'm being very careful to write these separate so that I have a final formula with no charges written in it at all. If I have a +1 and a -3, I'm going to multiply this one times 3 in order to cancel out the -3 charge. To have 3 of these, I need the parentheses to be able to show what I have 3 of. So this is probably the most complex formula you'll have because we have 2 polyatomic ions. In most cases, you're going to be dealing with only about 3 elements. This is one of the times that you would have 4. So the next slide, I will have the answers to the examples that are listed in the right-hand column of your notes, and then you will follow up with the additional assigned practice. I wrote the charges in above the words, and then you see the final formula listed there for you.